students, welcome to our torque discussion part 1, and this is the moment of force, and we have here the definition. So first, what is torque? A torque is the turning effect of a force, and torque is required to rotate an object just as a force is required to move an object in a line. So torque is created by force, but it also depends on where the force is applied and the point about which the object rotates. So let's say for this example, we have here the man who will open the door. So a door push at its handle will easily turn and open, but a door push near its hinges will not move as easily. So the force may be the same, but the torque is quite different. So let's try first to study the components of torque. I have here my diagram. So we have here the force that is being applied, and the triangle 1 represents the pivot, and we have here the distance or the lever arm. So therefore, we define torque as the force multiplied to the distance. But remember, this force must be perpendicular, and the distance is from that point to the pivot. So we have here the symbol. We have torque is equals to force perpendicular multiplied to the R, or better known as the lever arm. So what is the unit of torque? We all know that the unit of force is Newton, and then multiplying it to the value of the R, therefore the unit of torque is Newton meter. So remember that. Now, let's try to study the different formula for torque. Now, we have here the case wherein the force is perpendicular. Okay? Now, what if the force applied is not perpendicular, just like this case? So, therefore, let's draw the diagram. And then we have here the force applied, and then it has an angle. So let's try to draw it here. And then this is the F applied. Now let's try to look that there's an angle. So this will be our diagram. And then upon looking, we have here the Y component of the force, wherein this one, the angle, we have here, it is opposite to this Y component. So therefore, we could have this formula as sine theta, which is sine theta, we have opposite over hypotenuse. We have here the Fy over F up. And therefore, our general formula for the perpendicular force would be F up multiplied to the sine of that angle, and then we could get now that force which is perpendicular. So therefore, Fy is equal to sine theta multiplied to F up. Since our general formula is this, therefore we could summarize this into this formula. Now, remember that torque are vectors. So torques are cross product of force and distance. So we will study further what do you mean by cross product. So it's a different topic. But take note that torques are simply vectors. And remember, torques can rotate clockwise or counterclockwise. So therefore, if we're going to rotate it counterclockwise or counterclockwise, and that is a vector, the sign of it will matter. So if we have here the force applied, and we have here the pivot, and we have the distance or the lever arm, it will turn it in a clockwise direction. So it will rotate clockwise, and therefore the sign of it is negative. So we have negative torque. So let me just clear this picture. Now, how about on the second case, which is rotating counterclockwise? So we have here again a pivot, and then we have the force being applied. Now, we can expect that it will turn in a counterclockwise direction. So therefore, rotating counterclockwise will have a positive torque. Now, let's try to have our sample number 1. A force of 50 Newton is applied to a wrench that is 30 centimeters long. Calculate the torque. So we have here the given. The force downward, which is rotating, expected to rotate clockwise direction. And therefore, that negative 50 Newton. Why negative? Because it will rotate in clockwise direction. And the distance from the pivot is 30 centimeter or 0.30 meter. And the required is the torque. And what is the unit of torque? The unit of torque expected to be Newton meter. And therefore, we have here the equation. And then we have here simply the solution. The force is negative 50 Newton and the lever arm is 0.30 meter. Multiplying that would give us negative 15 Newton meter. Okay, now, if we're going to use this formula, which is sine theta, remember, we have here, it forms 90 degree multiplied to negative f up. And what is sine 90 degree is simply 1. So therefore, it will just be the same, negative 50 Newton multiplied to 1, and that would be still negative 50. And that will give us the same answer. Now, let's have here our sample problem number 2. A force of 100 newtons, 30 degrees from the horizontal, is applied to a wrench that is 25 centimeters long. Calculate the torque. The given here is the force upward, and then it is rotating counterclockwise. That is positive 100 Newton at 30 degrees. It is positive since it is rotating counterclockwise. The distance from the pivot is 25 centimeter or 0.25 meter. The required for our problem is a torque, and the unit is Newton meter. So our equation, here's our formula. We have the torque equals to force perpendicular times R. Since the force perpendicular is equals to sine theta multiplied to F up, we have now this formula. Plugging in the values, we have sine 30 degree times 100 Newton times 0.25 meter. And sine 30 is 1/2 multiplied to 100 is positive 50 Newton meter times 0.25. And therefore, it will give us an answer of positive 12.5 Newton meter. We have to take note that it is positive since it is rotating counterclockwise. Now let's look at our sample problem number 3. What amount of force is required to produce a positive 4.0 Newton meter torque at an angle of 50 degree, 10 centimeter from a pivot? So let's try to study our diagram here. The given here is a torque upward and it is rotating counterclockwise, and the torque is positive 4 Newton meter, 50 degrees. And the distance from the pivot is simply 10 centimeter or 0.10 meter. The force, the unit, the required here is the force, and the unit is Newton. And here's our equation. And we have to take note that torque is sine theta multiplied F up times R, since we're looking for the force perpendicular. And then therefore, we have here 4 Newton meter is equal to sine 50 degree multiplied to F times 0.10 meter. And solving for sine 50, that's 0.766. And then divide 4 Newton meter by 0.10 meter. And then we could have 40 Newton equals to 0.766 multiplied to F. Since we're looking for F, divide both sides by 0.766. And we could have F, which is 52.219 Newton. So our answer in two significant figure is 52 Newton. In summary, torque is a turning effect of a force. The formula of torque is torque equals to force perpendicular times R. And then therefore, we have to take note that it must be force perpendicular and the distance must be uh, from the pivot, and therefore this will be our generalized formula, which is F up sine theta times the R. The unit of torque is Newton meter, and it is a positive torque if it is rotating counterclockwise, and a negative torque if it is rotating clockwise. Now, we have to take note that the further the force of the pivot, the greater will be the value of the torque. So our next topic will be torque in equilibrium.